Okay, today, second lesson in chapter 12, we're going to talk about some techniques for finding limits. And yesterday we learned strategy number one. What's strategy number one? Plug it in. Strategy number one, plug in the x value. What's a limit?
Y value.
A y value. Okay. So let's look at plugging some stuff in. Number one, if I plug in the value they tell me, I would have 2 times 1 squared plus 6 times 1 minus 5. So that's 2 plus 6 is 8 minus 5, 3. Done. You guys try the second one. For B. Four minus 2 minus 1 is 1. 2 squared is 4 plus 2 is 6. 1/6. What's the strategy?
Plug in.
Strategy number one. Plug in. And number two, let's try that strategy again. Let's plug in. So if I plug in letter A, I would have 3 squared minus 9 over 3 minus 3, and I end up with 0 over 0. Uh-oh, the plug-in didn't work. That means we're going to try a different strategy. Strategy number two. Factor, or possibly some other kind of algebra, simplify then plug in. So you might have to factor, then like reduce or something, but we're basically going to do some algebra. That means in letter A, if I was doing that, then on the top I see x squared minus 9, which is now x plus 3, x minus 3, because that's the difference of 2 squares. Down below, I see an x minus 3, and I notice that those x minus 3's reduce. So really, this function that I'm talking about, this x squared minus 9 over x minus 3, is really acting like x plus 3. So now I can look and it goes, oh, hey, the x, I want to plug in 3. So I plug in the 3, and I get 3 plus 3, or in other words, 6 for an answer. So I do some algebra, and then I plug in. In part B, you probably haven't seen the factorization of a cube before. Have you guys ever seen that before? Some of you may not. Depends on which math teacher you had for Algebra 2, I'm guessing. So when you factor, if we plug in like we tried in the past and see what happens here, if I plug in the 1, I get 1 minus 1 over 1 cubed minus 1, which is 0 over 0, which is a nonsensical answer. I'm like, oh, that doesn't make any sense, so guess what? I'm going to try some algebra. When I try my algebra, on the top I get this x minus 1. And if you're an astute math student, what you realize is whenever they give you something like that, there's always some kind of, I guess people would use the word trick. They want you to be successful. They want you to find the answer. That means if something's going to work out, I need to get an x minus 1 on the bottom. And the factorization, the way this thing works, which is kind of unfortunate that they use x cubed and 1 because it's harder to see with those numbers, but here's how you work it. When you're factoring the difference of 2 cubes, whatever you see first, like the x cubed, the first parentheses will be the cube root of that. So that's why there's an x here. The second thing will be the cube root of the last number. So like if that last number would have been an 8, the number would have been a 2. But since it's a 1, the cube root of 1 is 1. Whatever sign you see transfers to the first parentheses in the middle. So cube root of x cubed, x. Cube root of 1, 1. Negative sign, put it down below. That's the first parentheses. The way that you get the second parentheses, which is actually a trinomial, is you look in the first parentheses and you go like this. square the first thing, square the last thing, and there's going to be an x term, so you multiply everything you see and take its opposite. So x times negative 1 is negative 1x, and I'm going to make it positive 1x. This is the factorization of that cubic difference. And then what ends up happening is I now see that the x minus 1 on the top and bottom cancel out, or reduce is probably a better word. What number is on the top?
1.
A 1. Don't forget the 1. And then on the bottom, if I plug in the number 1, I get 1 squared, which is 1, plus 1 times 1, which is 1, plus 1, which gives me a total of 3. And my answer is 1/3. Okay, so another technique that we could use is called rationalizing. In our class, what that meant is getting rid of the square root in the denominator. You guys remember that when we do that? Simplifying in our class. The weird thing is when you get to calculus, which this chapter is the lead-in for, the strategy for rationalizing is not used for the denominator. It's used for the numerator, which is really strange when you think about it. Our whole math career, we've been getting rid of the square roots on the bottom, and now what they try to do is they try to get rid of them on the top. Strange. It's a technique that works though. So as I look at this thing, what happens is I try, as always, always try to plug in first. So I try to plug in. And I get the square root of 0 plus 2 minus the square root of 2 all over 0. Or in other words, darn it, I get 0 over 0. No good. When that happens, I have to use another technique. Can't really do what we've thought about in the past, like factoring with square roots. So we do something called rationalizing. Rationalizing means look at whatever you see that has square roots, do the conjugate. Remember that word?
Yeah.
Conjugate? So when I do the conjugate, what that means, in this case right here, is that I'm going to be multiplying by radical x plus 2 plus the square root of 2, top and bottom. And don't forget this has a parentheses around it. Now the reason that you're doing this rationalization, is because I have two things that are being multiplied, like when I FOIL the two binomials that are being FOILed out, I have the difference of two squares kind of thing. So when I multiply the square root of x plus 2 times the square root of x plus 2, or in other words, these two things, I just get x plus 2. And if I were to look at the outers, the square root of 2 times the square root of 2, I just get 2. And there's a minus sign in between. And if I was FOILing and I look at the inners, I have a negative set of these things and a positive set of these things. They cancel out. And that's why we use the rationalization thing with the numerator, because now there are no radicals on the top. Now you would think that this doesn't really help us, but watch what happens. On the bottom, I see the stuff that was in the pink, that square root of x plus 2, plus the square root of 2, and then the thing that's left over from the original fraction is the x. If I simplify what's going on the top I get an x, and on the bottom I still have that parentheses and the x, the square root minus the square root thing. Or in other words, the x plus 2 that was in here and the 2, the plus sign in between. Notice how top and bottom now, the x's reduce. So really what's going on is the function that you saw is acting like 1 over the square root of x plus 2 plus the square root of 2. And now that we've simplified, we can shove in a number for x that they originally told us to shove in. What were we supposed to shove in? A 0. So I shove in a 0, and what ends up happening is I get a 1 over the square root of 2 plus the square root of 2. Now, of course, you would have to simplify this in our class, but Now you've gotten rid of all the possibilities of what's going on that's wrong. So if I was simplifying this, I would go with 1 over 2 radical 2's. I know that when I try to simplify that, our strategy was to multiply the top and the bottom by square root of 2. Or in other words, what happens is the square root goes up to the top and comes off the bottom. So you really have square root of 2 over 2 times 2, which is 4. So the answer is the square root of 2 over 4. Yikes.